Hello everyone, this is Ravi, also known as CodeCat15, and I welcome you to the iOS Cafe channel. In today's session, I'll be talking about the architecture of SwiftUI. Now before getting into the architecture, let me inform you that Apple has not released any official documentation on what the architecture pattern of SwiftUI should be. But they do have some demos to show you how to achieve certain functionality in SwiftUI. The good part of the demo is that it tells us how to do something, gives us a certain direction, and the bad part about the demo is the coding structure and the style that is used in a demo is very different from what we use in a client application. In a demo, you can do certain things and get away with it because the intent of the demo is just to prove and show how to achieve certain functionality. Whereas in a client project, we follow certain guidelines to ensure that the code is clean, maintainable, and flexible to change. So a demo should not be assumed as a guideline for best practice, unless the demo specifically mentions that this is the best practice and explains why this is the best practice. For example, in the fruta demo, Apple is using a model class, and this model class has properties, has some authentication function, some extensions to handle smoothies and accounts, which are two entities. It has some StoreKit implementation and also some private logic for the StoreKit implementation. So basically this model class is acting as a repository that handles two entities and some StoreKit related functionality. Now looking at this structure, you can easily say that this model class is doing too many things. And that's okay because this is a demo. And the intent is to show you how to do things. If this was a client project, then I'm pretty sure that you would have handled this code in a different way, because we can clearly see that the model class is handling too many responsibilities. And hence demos should not be considered as a writing in stone for best practices. Having said that, let's talk about SwiftUI architecture. When we talk about what's the architecture of SwiftUI application, we come across MVVM, which is model, view, view model. Now this pattern has been incredibly successful in UIKit, and the best part about MVVM is that this pattern is very simple to implement even in SwiftUI applications, and it works well. Let's have a look at a very simple sequence diagram with MVVM. So over here you can see we have a view, and the view is initiating a call to authenticate a user. Here we have a view model. The view model validates the request, and this validation is nothing but a Swift file where we have the logic for validation. The validation returns a validation result, and if the result is successful, the view model then sends a request to the login service. The login service creates a URL request and sends it to the HTTP client. You can think of HTTP client as a simple utility where we have the URL session code. And once the HTTP client returns the response is sent back to the view model and from the view model to the view. So this is a very simple sequence diagram of a MVVM approach. So over here, the view model is acting as an orchestrator which retrieves the information demanded by the view. The best thing about MVVM is that each layer over here is handling its own set of responsibilities. Now there are few developers who would not do this level of decomposition and would write everything inside the view model. And if you write everything inside the view model, your code is going to work. But then it creates another issue, which is massive view model, just like massive controllers. And hence such level of decomposition is needed to keep the code more maintainable. Please note that a view model should not and must not contain any UI related details. Like you cannot pass gesture objects or any table view or labels to the view model. Because if you do that, that's a violation of the MVVM pattern. Now before we move ahead in the video, I'm not proposing using MVVM with SwiftUI. If MVVM works for your project needs, then surely go with MVVM. Or you can go with any pattern that suits your project needs till the day Apple releases any official statement on the SwiftUI architecture. And I think it's a pretty pragmatic approach. Recently, I came across a post in the Apple developer forum which speaks that how MVVM may not be the right pattern for SwiftUI. Now please note that this is not an official guideline or any sort of official documentation from Apple. On further scrolling, I can see that there is a code over here where we have a model, we have a product list, and we can see that this list is being populated with the help of the product model, or you can use the product model inside the product view. And over here, you can display all the product or maybe purchase the product by using the product model's purchase function over here. So it seems that a suggestion is being made to eliminate the view model and just use the model and the view. There is also a sequence diagram. So in this sequence diagram, we can see that the user will make some action in the view will send a message to the model, and the model will perform some operation, and it will notify the view. So I implemented this pattern for a small login module. So let's switch to Xcode and explore it out. Let's have a quick code walkthrough. So I'm inside the login view, which has an observed object property of the login model. And the login model has two published properties, that is user email and user password, which are binded to the text field and secure field. On the click of the button, I am authenticating the user through the function of the login model. And now let's go to the login model. So here we can see the two published properties. we have an authenticate user function which returns the login response. We are doing some validation, and then we are creating the URL request, and then we are sending the URL request to the HTTP client. The HTTP client is nothing but a class where we are making the API call. So let's run the application. So if I don't enter anything and tap on login, I get an alert. And there you go. So we can see that by following the model view approach, our code definitely works. We can get the output. If I present this entire flow with the help of a sequence diagram, this is how it's going to look like. So when the user taps on the login button, a request is made to authenticate the user from the view to the model. What the model does is, it validates the request by making sure that the email ID is valid and the password field is not empty. It then goes ahead to create the URL request and then makes the API call with the help of the HTTP client. The HTTP client sends the response, and the response is then sent to the view. So this is the entire flow of the model view approach. So should I just go ahead and use this pattern over MVVM? Because I can definitely use MVVM and get the same results. So which one should I pick? Whenever you have two patterns or a solution to a given problem, then a technical comparison is must, because only then you will know what the right solution is. Let's have a detailed look at the model view approach and see what's going on. Let's talk about the model first. The very first thing I want to highlight is the responsibilities that this model class is handling. It is doing validation, then it's creating the URL request, and then it is making the API call. So overall, this model is handling two different responsibilities, validation and API calls. The properties that we see over here, they are acting as a binding for the UI element. So overall, there are three responsibilities. Now, since this model also has API calls, that means it is doing some data retrieval. So it is also acting like a repository layer. Overall, the model is handling all these responsibilities. Handling multiple responsibilities also breaks a principle known as separation of concern, or some may even call it as single responsibility principle. This principle states that one class shouldn't be doing too many things. Now, knowing about the responsibilities that the model handles, let's revisit the sequence diagram of model view approach. In the model view approach, we have a model that is doing too many things, as we can clearly see that the model is playing multiple roles and handling multiple responsibilities. Coding like this in the live project where we are dealing with too many complexities is a bad idea. You may think that the model view approach just breaks a separation of concern. Well, actually it breaks one more principle. So let's switch back to xcode and see what principle it breaks. In any application, it is very common for a model to have relationships. Like in this case, I have a class product and this is having some published properties. We have a function called as getProducts, and over here we are making the API call to fetch the product and we are returning it. We have another model which is called as the order, and here we have a property of products and the total price. We have a function which calculates the total price of the product. And this is a pretty basic structure for any application. Now in the model view approach, I can do something like this. Now in the order model, I can access all the functions of the products. So this approach is breaking an object-oriented principle called as abstraction. Because in the order model, I can either get all products or delete them. Now some developers may debate on this, saying that in the code review, we will make sure that our developers don't code like this. So basically this means that these developers are agreeing to some extent that this function shouldn't be accessed like this, because it's bad and someone can abuse it. And if this function shouldn't be accessed, then it shouldn't be in the model, because you aren't gonna need it. And that's Yagini principle. If you don't need something, don't add or expose it. So overall, we know that there are three principles that this approach breaks: separation of concern, abstraction, and Yagini. Even for a second, let's assume that you break down the responsibilities of the model into multiple layers, where the model is now acting as an orchestrator. It still doesn't change the fact that you have weak abstraction in the code. Role of a view is just to request information, and the view does not care where that information comes from. So for example, in this case, in the model view approach, the view is requesting the model for certain information. And if I replace this view with a view model, the view still remains the same. And it's not doing anything extra. It is just requesting for information. It's actually a good practice to keep the views as simple as possible. Now I do agree that a view can do a lot of things. And as a matter of fact, you can go ahead and dump everything inside the view. Ignore all the patterns or best practices, and your code will still work. But then I think we all know the issues of doing that. The code becomes difficult to maintain and is tightly coupled. Let's come back to the Fruta demo of Apple. In the Fruta demo, we have a model class, which I've shown at the start of the video. And this model class is handling too many responsibilities. And that's okay, because this is a demo. And the intent is to show you how to get things done. But if we have a look at how this model class is being used in the view, you'll see that this model is acting as a view model. So inside the order placed view, we have this model again. And over here you can see that model.order is being accessed, and order is a property which is this one. In the rewards view, we again have the model, and look at how the model is being used, how it's accessing a function. It's very similar to a view model. So now the question is MVVM the official architecture of SwiftUI? Well, I don't know. As I said at the start of the video, there's no official documentation which says so, but I'll leave this to your judgment. With the model view approach, once again from massive controllers to view models, we all will be talking about massive models. Sure that there are better ways of writing clean and manageable code in SwiftUI, which don't break any coding principles, but we will leave that conversation for some other video. That being said, thank you so much for watching this. If you're new to the channel, then please subscribe, share and like the video. And do join the iOS Cafe on Discord. It's a cool community with amazing iOS devs across the globe. The invitation link is in the description. Have a nice day and happy iCoding. Bye-bye.